Hello everyone, welcome to the second part of the chapter Human Eye. In this part, we would be discussing about defects of vision and their correctness of the eye and some numerical based questions. So there are three common defects of the vision: myopia, hypermetropia, presbyopia. First is your myopia, that's your short-sightedness or nearsightedness. In this, a person is unable to see the far object or the distant object clearly. And what is its cause? Due to high converging power of lens, that means short focal length, or due to eyeball being too long. How it can be corrected? Concave lens is used for correcting myopia. But again, here is a note point. Focal length of the concave lens should be such that it produces virtual image of the distant object as far point of the myopic eye. And also it should reduce the converging power of the eye lens. Next we have hypermetropia, long-sightedness. That means you are able to see the far objects but unable to see the nearby object. It's just opposite of myopia, and it is caused due to low converging power or large focus length. Then due to eyeball being too short. How it can be corrected? It can be corrected by using a convex lens. Again, note point. Focal length of the convex lens should be such that it forms a virtual image of the object at the near point of the hypermetropic eye, and the whole purpose of the convex lens should be to increase the converging power of the eye lens. Last we have presbyopia. This is especially for the old age person, in which he or she is unable to see nearby objects clearly due to loss of power of accommodation of the eye, and it is also corrected in the same manner as that of the hypermetropia, that is by using spectacles having convex lenses. What is a cataract? Medical condition in which lens of the eye becomes progressively cloudily, resulting in the blurred vision, is your cataract. And in this, a person becomes cloudy, means he thinks the objects very cloudily and not clearly. Now let's solve some numericals which usually come. Question says far point of myopic person is 80 centimeter in front of the eye. What is the nature, power of the lens required to correct the defect? Now as we know, myopic eyes can be corrected by using a concave mirror, isn't it? According to the question, what it is given? Far point is given. Far point means image distance is given. That is your V. It's your 80 centimeter. But as we know that image is formed on the left side, so it would be considered as a negative sign over here, isn't it? Since it is in front of the lens. Now when I talk about the object distance, that means object distance must be somewhere in infinity. Then we have a focal length, what we have to find out. Now as we know, according to the lens formula, this you might have studied, 1 upon V minus 1 upon U equals to 1 upon F. Now let's just put the value over here. That would be 1 upon minus 80 minus 1 upon infinity upon 1 upon F. 1 upon infinity is 0, so we can consider it 0. So minus 1 upon 80 would be 1 upon F. Let's cross multiply it, then F would be considered as minus 80 centimeter. Now when I talk about power, power is your inverse of focal length but in meters. Now 100 centimeter equal to 1 meter, this we know. So 80 centimeter would be just cross multiply 80 into 1 upon 100, that would be 80 by 100, 0.8. So power would be 1 upon minus of 0.8. Do not forget the negative sign. So I'll be getting the power somewhat 1.25 diopter. since its unit is diopters. So the power of concave lens required is minus 1.25 diopter. Now let's move on to the next question. Near point of the hypermetropic eye is 1 centimeter. So you have to find all. That means you have to find the nature, power of the lens required, and other things also. So let me solve it here only. According to the question, what it is given, the object distance, that is u, is your 25 centimeter. But here it would be minus. Why? Because it is formed on the left side. And the image distance is also forming on the left side. So we would be minus 1 meter. If I'll convert it into centimeter, it would be minus 100 centimeter. And this is the near point of the defective eyes. Focal length again we have to find. According to the lens formula, 1 upon u 1 upon v minus 1 upon u equals to 1 upon f. So it would be 1 upon minus 100, 1 upon minus 25 would be 1 upon f. Negative negative goes plus, so I'll write it on the left side. 1 upon 25 plus 1 upon 100 equal to 1 upon f. Let's take its LCM. It would be 100 minus 1 plus 4, 1 upon f, minus plus 3 upon 100 equal to 1 upon f. F would be 100 by 3, that is 33.3 centimeter. Now let's solve further for it. We have also to find power. Power is your 1 upon f, but in meters. If I'll convert this in meters, what would I get? It would be 0.33. You can convert it on your own. 100 upon 33, that is plus 3.0 diopters. So the power of the convex lens, this is your hypermetropia, so it is 3.0 diopter. Okay, so